compounds that we looked at in our previous lessons were called ionic. And the reason that they are called ionic compounds is because they're formed because of the attraction between the positive and the negative. Now, the positive was always a metal, and the negative was always a non-metal. Okay? And the names for those ionic compounds came from the name of the ions in the compound. So, for instance, our example was sodium nitride, and sodium nitride was named because it had sodium as its metal and nitride as its non-metal. So sodium nitride is an example of an ionic compound, meaning it is made up of ions. Now there is another type of compound, the one that we're going to look at today. I'm going to use a different colour now. And these ones, they share electrons. Okay, they have a different name or a different naming system. And we call these ones covalent compounds. So we have ionic, and now the one that we're introducing is things called covalent. The good news for you is covalent are actually way easier. Okay? So when it comes to covalent, our first example is water. And we can see in water, hopefully you know the formula is H2O. You've seen that one before. And all we're doing here is we're saying that one molecule of water is made up of or consists of 2 atoms of hydrogen, and I can see that if I unhighlight that, 2 atoms of hydrogen and 1 atom of oxygen. Oh. And next one, if we do this one together, I have 1 molecule of methane. And what does 1 molecule of methane consist of? What? Is it chloride? It's just a C by itself. Yeah. So it consists of 1 what of carbon? Very good. 1 atom of carbon joined to, what does this next one next to it represent? How many hydrogens? 4 what? Good. 4 atoms of hydrogen. So what I'm going to ask you to do now, can you fill in ammonia gas for me in the same exact way? And then the very last one, does anyone know what CO2 is? It's what we breathe out. Great. So in this box here we can write carbon dioxide. And at room temperature, aka where we are right now, what does carbon dioxide exist as? Is it a solid, a liquid, or a gas? Great. Gas. So can I get you to fill in those 2 final boxes? Just breaking those down for me. There's going to be a few that you need to remember the names and formulas, and they are the exact same 4 that we'd been talking about a second ago. So the first one is water. And in water, we can see the 2 hydrogens bound to 1.
Oxygen.
Very good. All right. Our next one that we had a look at was methane. So up the top here, we're going to write methane. And methane, like most of these, exists as a gas. And when we talk about methane gas, it is made up of what? What did we say methane was made up of?
1 carbon.
1 carbon atom. So in the very middle of this one, I'm going to draw 1 carbon atom. And it was bound to how many watts? 4 hydrogens. So together, we're going to draw these spread out around that carbon like this. And I have 4 hydrogens. Okay? Now, to help your understanding of why these are bound together and how they share these electrons, I'm going to draw one off to the side. Okay? And so what I'm going to do, if I have a look at methane gas, and you could actually do it right here if we do it quite small together, is I'm going to start by drawing the electron configuration for carbon. So the electron configuration for carbon is C, 2 electrons in its inner shell. How many electrons does carbon have in its outer shell? Use your periodic table. How many electrons does carbon have in its valence shell? 4. And now normally we've grouped them together, but in this case I'm actually going to write 1 carbon electron across each side like this. How many electrons does carbon really want in its valence shell?
None. Oh, 4 valence.
It wants a full valence shell. And how many electrons are found in a full valence shell? 8. And so it binds with hydrogen. Now hydrogen has how many electrons altogether? It's the first element. It only has 1 electron. And it binds with 4 hydrogens. And you'll notice that I'm drawing the hydrogen electrons like this. So what ends up happening is these 4 hydrogens see that carbon has a bit of a problem. It's short 4 electrons. And what do? They share their electrons. So how many electrons does carbon now have in its valence shell? So is carbon really happy? Yeah, because carbon now has 8 electrons in its outer shell. What about hydrogen? Hydrogen wants how many in its outer shell ideally? If we look at our periodic table and we have our electron configuration rule, it was 2, 8, 8. So how many electrons does hydrogen really want in its outer shell? 2. And so if we were to have a look at hydrogen, how many does this hydrogen here have in its outer shell? 2. How many does this hydrogen have in its outer shell? 2. This one? 2. This one? 2. So this is a win-win situation. Not only does hydrogen get its 2 electrons in its valence shell, but carbon gets its 8 electrons in its outer shell. Okay? And you're probably thinking, but this electron, it's not really going around hydrogen. They tend to float like this. Okay? So they can move all around so that everything is nice and evenly spread. Okay? They're sharing these electrons together. So what we're going to do now, we're going to come down, and our next one was it ammonia? It was ammonia. Okay? And for ammonia, we can draw ammonia gas with, again, 1 central nitrogen and 3 hydrogens. Now, if I was going to be really mean, okay, I could say how many electrons are in nitride's outer shell? How many electrons are in nitrogen's outer shell? 5. How many does hydrogen have in its outer shell again? 1. And how many hydrogens do I have here?
3.
So how many electrons do I have altogether?
8.
And what does that make? It makes a complete outer shell for? Yeah, 4. It makes a complete outer shell for nitrogen, and nitrogen is going to share 1 electron with each hydrogen so that they all have a complete outer shell. The final one, a little bit different, CO2. So we have 1 carbon in the middle and an oxygen on either side. So to finish us off today, okay, with this idea of covalent compounds before we finish a table together, covalent compounds are joined non-metal and non-metal. So covalent compounds are formed by joining non-metal and non-metal. Now, they exist as separate molecules, and what I mean by that is if I had 1 molecule of water, H2O, it exists separately next to another H2O. So I can have lots and lots and lots of H2Os next to one another. Okay? So we now have 4 really important words that we're going to define together. So let's have a look at what these 4 words are. Some are familiar, some are new. So number 1, atom. As we talked about previously, an atom is just the building block of all matter. So we can have carbon atoms, hydrogen atoms, aluminium atoms, you name it. The next word is molecule. And this is where we have 2 or more atoms joined together. But you'll notice that these atoms can either be the same thing or a different thing. So water, are they the same atom in water? No? What do we have in water? What kinds of atoms do we have in water? Hydrogen and oxygen. How many atoms do we have all together in water? 3, because I have 2 hydrogens and 1 oxygen. How many different types of atoms do I have? 2. So 3 atoms altogether. How many types? 2. When I look at oxygen gas, however, how many atoms altogether? 2 atoms altogether. How many types of atom? 1. Very good. Our next definition, element. I'm going to use different colours for all of these words. An element is a pure substance. So an element is only made up of 1 type of atom. So how many elements do I have, or how many different types of atoms do I have in gold here? 1. How many atoms do I have altogether in gold though? 12. So, what about oxygen gas now? Oxygen gas, again, I've only got one type of atom, but how many atoms do I have altogether? So, oxygen and gold are both molecules and elements. They're both, okay? Because there's two or more atoms joined together, but they're an element, meaning that they're pure, they're only that one type of thing. Now, our final term is the opposite of an element. It is where we have a compound, which is a substance made up of two or more different kinds of atoms. So like water that we looked at right at the start. Water is made up of 2 hydrogens and 1 oxygen. Okay? So we've got more than one atom. We've got 3 atoms altogether, and we've got 2 different types, hydrogen and oxygen. Carbon dioxide, I've got 1 carbon bound to 2 oxygens. Methane, I've got 1 carbon bound to 4 hydrogens. So how many atoms do I have altogether in methane?
5.
How many different types do I have?
2.
So, because I've got 2 or more different types of atom, it is going to be a compound. Okay? So, our final piece of the puzzle today is filling in this table together. So let's go through. An ionic molecule, the thing that we were talking about before camp, is a compound that is made up of a metal and a what? Very good. When we talk about covalent molecules, so the ones that we've just looked at today, they are made up of 2. Very good. So non-metal and non-metal. Now, in terms of their electrons, when we talk about ionic, they can either gain or lose electrons. So sodium, for instance, likes to lose 1 electron, making it +1. Chloride likes to gain 1 electron, making it -1. What about covalent? They like to share their electrons around, okay? So that everyone gets an even share of those electrons. Now, when we talk about molecules, do they both form things with more than 1 atom? Yeah, so both of them are a big yes. Okay, both of them form molecules. So what's an example of an ionic molecule then? What's something where we have a metal and a non-metal added together? Copper chloride. So we could have copper 2 chloride. So we would write copper, which is our metal. Copper 2 has a charge of 2+. So how many chlorides do I need to balance out the 2+? 2. So I write CuCl2. What about a covalent molecule? We've just learnt about 4 of them. What is a covalent molecule that we've just learnt about? Ammonia gas, okay? And ammonia gas is NH3. Okay. Now, out of all of those 4 covalent ones, so water, methane, ammonia, and carbon dioxide, you do need to learn those. Okay? You need to have those ones fresh off the top of your head.